Today our topic is compound inequalities. So our essential question is, how can I write and graph compound inequalities? First off, we need to know what is a compound inequality, and it is two inequalities joined by the word and or. So it can either be joined by the word and or the word or. First, we're going to talk about and compound inequality. So in words, we have all real numbers less than 6 and at least 2. So if we're numbers that are less than 6, we would have x is less than 6. We could have numbers like 5, 4, 3, 2, 1. All of those numbers are less than 6. At least 2 means we can be at 2, but we can't be any lower than 2. So that'd be like 2, 3, 4, 5, 6, and so forth. So if you see, there are some overlapping numbers here. We have 2, 3, 4, 5. They overlap in there. So we would have x could be greater than or equal to 2. And we would join these inequalities with the word and. We would say x can be less than 6 and x can be greater than or equal to 2. We can also write this as one inequality, so x is less than 6. And then if we put the 2 over here, all we have to do is flip this inequality to less than or equal to. And then it's a nice little between. X is between those two numbers, 2 and 6. To graph this, we start with putting the circles on. So we say x is less than 6. So let's put 6 here. We can do 5, 4, 3, 2, 1. 6 would have an open circle because it's just less than. Then if we look at our second inequality, x is greater than or equal to 2. So at 2, we'd have a closed circle. And then we want to shade in between them because we're less than 6. So less than 6 would go this way to your left. And greater than 2 would go to our right. So we're shading right there in the middle of the two. For an or compound inequality, in words, we have all real numbers greater than 6 or at most 2. So let's write two inequalities. All numbers that are greater than 6, so x is greater than 6, or at most 2. So at most 2 means 2 is your maximum. We can't go any higher than 2, so x could be less than or equal to 2. So now to graph that, we make sure that we can fit 2 and 6 on our number line. X is greater than 6. We would put an open circle at 6 and shade to our right. X is less than or equal to 2 would have a closed circle at 2, and we're shading the numbers that are less than 2, so we go to our left. So this is a split apart graph, whereas our and was a between graph. So that's one way you can remember how the graphs are supposed to look. Next, we just have some real-world problems. A crane sits on top of a camera car. So we have our camera car here. We've got the crane, and it's holding up this camera to record images. It faces toward the front. The crane's maximum height is 18 feet, and the crane's minimum height, 4 feet. Write and graph a compound inequality that describes the possible heights of the crane. So our maximum height is 18. That means, can we be bigger than 18? No, we could be smaller than 18. We could be equal to 18, but we can't be any bigger than 18. Then our minimum here is 4 feet, which means We can't go below 4. We can go above 4, and we can be equal to 4. So now we need to figure out if that is an and or an or. Should we put an and or an or in the middle? Now, the best way to figure that out is to graph it and see, do we have an and graph, which would be a between graph, or do we have an or graph, which would be an away? All right, so let's graph this. X is less than or equal to 18, so we put 18 on our graph. Less than or equal to is going to go this way towards 16 and 14. Now let's count down to 4. There we have 4. So let's graph X is greater than or equal to 4. We'd have a closed circle at 4. Greater than would be 6, 8, and 10. So we'd go this way. So our two graphs meet in the middle. It's a between graph. It's an and. So we'd say X is less than or equal to 18, and X is greater than or equal to 4. All right, last question. In order to be admitted for a certain ride at an amusement park, a child must be at least 36 inches tall and less than 48 inches tall. Write and graph an inequality that describes the height of children that cannot be admitted. All right, so if you can be admitted to be at least 36 inches tall, that would be X is greater than or equal to 36. So then those who could not be admitted would be the opposite of that, be X is less than 36. So this would be the piece that we want. Then for children that can be admitted, they have to be less than 48 inches tall. So if we write that X is less than 48, the opposite of that would be greater than or equal to 48. Because you have to be less than to be admitted. So if you're exactly 48 inches tall, you would not be able to be admitted. All right, now we need to figure out, do we put an and or an or in the middle here? So we need to graph them. Let's start with graphing X is less than 36. We put 36 here, open circle, and then we shade to the left. Now we'll count up to 48. There we have 48. So now we can graph X is greater than or equal to 48. Close circle at 48. And it's greater than, so we shade to the right. And there, if we look, we have an away graph. They're in the opposite direction, so that's an or graph. So in the middle here, we would put or, and there we have our compound inequality. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.